All right, so we're using the segment addition postulate again. So that means, again, we add this part to that part and we'll get the distance from here to there. So the endpoints of the entire segment. All right, so SK is 13x minus 5. And then we have this segment here, KY, which is 2x plus 9. Now remember, we got to add this segment to that segment. Once we combine those two segments, it should come out to SY, which, looking at the diagram from S to Y, is all the way from one side to the other side. And that would be 36 minus x. Now for this one here, for all the questions, it's asking us to find each of these lengths. So we have to find out what x is. We're going to have to find out SK, so the long segment, KY, which is the shorter segment, and SY, which is the entire segment, the entire length of the whole figure. So let's go ahead and follow our rules of algebra. So first thing we got to do is look for parentheses, which there's none. If there's no parentheses, look for like terms, which in this case, I see that there are two like terms. I have an x term here and an x term there. X term here, x term there. So 3x plus 2x would be 15x. And then here I would have my regular number, so that's going to be negative 5 plus 9, but it's probably easier to think of it as 9 minus 5, which 9 minus 5 would be 4, and that's just an easier way of gathering that number together. All right, so now I've taken care of all my like terms on both sides of the equal sign. It is an equation, I almost said equation. But now we have to determine where we're going to put our variable. So which side is the variable going to go on? So let's look at the two options. I could either move it to this side, which if I wanted to move it to the left, I'd have to minus 15x from both sides, but that's going to cause a bit of an issue. It's going to cause a bit of an issue, not a big issue. If you did that, you're not going to get the wrong answer, but it's a lot easier to kind of spot when something's wrong, when something's off, when you keep it positive. So that's what I'm going to do. I'm going to keep it positive. So I want to get rid of this 15x. So I got to do the inverse, which is to minus 15x. So minus 15x from that side as well. And just for this one, since this is kind of a simple problem, you know, maybe you're a little bit rusty on this. But I usually like to do one thing at a time if I can. Sometimes if I know I'm going to run out of space, or if I have a lot of work and a lot of steps to do, I'll usually kind of combine steps. But again, I don't think we're in that bad of a hurry or anything. Oops, and that should be negative 16 actually. Oops, wrong color. All right, now we end up with a negative number, and like I said, it doesn't matter what you do. You're still going to get the right answer, but there is a bit of a problem here, and that is now we have to work with negative numbers. Right? If we just kept everything positive, that would be a lot easier to work with, a lot easier to do. And sometimes when I'm looking at this, I'm thinking to myself, wait a minute, you can't have a negative length, right? Because you can't have a negative piece of string. It just doesn't work out that way. You can't have a negative string. So normally if I saw something like this, I'd be thinking, oh, well, it's wrong. We made a wrong step somewhere. But we didn't do a really good job at deciding which side to put the x on. But it doesn't matter. Like I said, we're going to get the right answer anyway, because 16 and the negative are going to cancel. And now I just have to do a negative divided by negative, which is a positive. So we do get 2 here. So at least we know that the x value is supposed to be 2. So let's go ahead and go down to the next item. And it says that we should find SK. So SK is this longer segment, but it also tells us up here what we should put there. So to find SK, I'm going to take 13x minus 5, but I'm going to take out the x and I'm going to substitute it with what I know x is, and that's going to be 2. So 13 times 2 would be 26. I said 26 minus 5. And then again, we write it the way we should. So SK equals 21. And now we got to find KY. So KY is this expression here. So KY is 2x plus 9. But again, we know that x is 2, so I'm going to go ahead and put that in there. So 2 times 2 is 4 plus 9, and that would be 13. Okay, so we also have to find sy, and there's 2 ways we could do this. I could plug in 2 up here to sy, so that'd be like 13 times 2, sy is this one here. 36 minus 2, which actually isn't that tough. That might have been the easier option. We would get 34 because 36 minus 2 is just going to be 34. But if we didn't want to do that, let's say that this was a very complicated problem, well, we could just add these together. 1 plus 3 is 4, and then 2 plus 1 is 3, right? So that's using the segment addition postulate, right? We just added them together. That's all we had to do. We didn't have to do a whole lot of work for that last one. We could have plugged it in from the beginning, but that probably wouldn't, well, we kind of already did because we already did the 2 smaller segments, but either way is fine. So you do have a little bit of choice on how these would be done. All right, and now there's going to be another part. For this one here, well, let's see, how can I do this one? That would be really easy. I'm going to go ahead and switch over to the other one really quick, the other slide. So I'm going to have to do a new screen share. I'm going to go back over to the original document. And here you can see the one we just worked on right there. That was number 7. And here we're just filling in some of these things. So just kind of a reminder on some of these things here. The midpoint of a segment is a point that divides the segment into 2 congruent segments. So for this one here, I'm going to go ahead and use a bit of a visual aid here. I'll use my scissor. Use this one here. I like to keep one of my scissors clean in case I have to open food. So I have a bit of a segment here, kind of a longer segment. Right, and then we're looking for a midpoint. So the midpoint would be maybe somewhere right about there. And we've got to break it into 2 congruent segments. So how could we do this so that we break it into 2 congruent parts? Well, what we could do is join the endpoints, because in this case it's a string. I can fold it and hold it like that. Grab our scissor and kind of pull the line and then cut it. And that should give us 2 very close in length strings. All right, but a scissor doesn't always cut straight on. So this is about as close as we could get it. But the point I wanted to make with that is that if you fold it in half, oh, it almost looks like a circle. If you fold it in half, you're gonna get 2 very similar length segments, pretty much congruent.
Mr. Nez, we didn't see your demonstration.
Is your camera on?
Yeah, we just see your worksheet.
Can anybody else see mine? Can anybody else see what I just did? If you don't have a mic, you can always use the chat.
Yeah, I saw it.
Yeah, I saw it.
Okay, so I think with yours, it's you have your video off.
Thank you.
You got to mess with the Zoom a little bit. I don't know, somehow it turns off the thing. Like, I think you can do it. Yeah, okay, I did it right here. Now I turned mine off. Okay, there we go. Yeah, so there's a little tiny bar and it has like 1, 2, and 3 thingy on there. I don't know, does that help? Can you see it now? Well, this is the string I used. But that's all I did was just cut the string in half to just show that, well, I don't know if these are the same ones because I did this earlier today as well. I don't know which one's which. But anyway, yeah, I just folded it in half and cut it. So the midpoint would be where I cut the string, and we have two congruent segments. So that means that I have two strings that are the same size. They're both exactly half of it, but that's the point of it. Now here I have a diagram, and let's read what it says about it. A line, ray, or segment that intersects a segment at its midpoint. Now remember, only a segment can be bisected because lines go on forever and a ray also goes on forever. Now we bisect that segment and call that the segment bisector. Okay, really fancy name on that, right? Sometimes names like that are good. You know, you want names that describe what something does. Okay, so like if I said a blender, you know, if I ask you what a blender does, you'd be like, oh, it blends stuff? Yeah, see, makes sense. But then there are some things that are named that don't make any sense. And you might have done this before, like you might have watched a movie saying, wow, that movie has a really cool name, and then you watch it and it's about something entirely different. Or if this has ever happened to you too, because this is a true story, and I think most people might know this story. So one day my dad and I are watching TV. This is like a long time ago, years, like decade or more ago. My dad and I are watching TV and an advertisement, what do you call it? A movie preview trailer shows up, and it's for the movie The Notebook. So I don't know if you guys have ever heard that movie, The Notebook, but in the preview, in the trailer, they have like a war scene, and there's like planes, and there's like soldiers in World War II doing stuff. And my dad and I were like, hey, let's go watch that. And we watched the movie The Notebook, and it turns out it was like some lovey-dovey movie, and it like some romantic movie, and it just like there was absolutely like all the scenes of action were in the preview. So it was just like a short flashback, and that was it. It was like, we're like, dang. All right, anyway, so I was just getting on to names. So segment, bisector, bisects a segment. Makes sense? Anyway, so in the diagram here, we have B, which is our midpoint. Midpoint of AC, so A to C. So again, just imagine it like that string, okay? We pull that string, and then this line here, like the scissor, just sort of goes across there, and it bisects them, it cuts them. So remember, bi means two, like bicycle, or binocular, right? A binocular has two lenses in it that you look through. Not like a telescope, not like those old timey ones that, you know, you see in pirate movies and stuff like that. But yeah, binocular is a little bit better because it allows you to see it twice, so that way you can kind of tell how far something away is. Anyway, so bisector just means cut it in two, and it's the bisector of AC. All right, I'm gonna go ahead and go to the next one, which it looks like we have some examples here, and I'm gonna go back and we're gonna work on some of these. Let's see, where is the one that we would have left off at? Okay, so this is the one that we're looking at, but what I want is I want this number here, because we're gonna work on it together. I would prefer to work on it together whenever I can. And let's go back over to the work page. So there's 7. Oh, it looks like it's already there. Let's see, 7, 8, 9, 10, 11, and then it goes to a new problem. Okay, so I guess we have enough to finish this out. All right, so Q is the midpoint of PR. So these are sometimes in a problem like this, when they tell you something, especially in geometry, like in this case, we are being told Q is the midpoint of PR. All right, we have to assume it's true because they told it to us. And sometimes, if you've ever taken a test like the ACT or the SAT, sometimes the diagram does not match what they're talking about. And that's because they don't want you to find any shortcuts with it. So be careful with that. So sometimes like when they tell you something and the diagram's like, wait a minute, that doesn't look like a midpoint. You just have to take their word for it. So always go with what they tell you and not always with what you can see on the diagram. Just, again, something to keep in mind for the future. If they tell you something, just take their word for it. Just assume it's true. They want us to find the value of x. So what can we put in for x to make this side equal to that side? Because remember, when you bisect it, that cuts it directly in half, and that means both sides would be the exact same size. Now, we don't know the full thing. We don't know the full length of the entire segment, but that's okay. We don't need to know that. Right? Because what some people might do is do something like, put plus in there, because that's what we did before. But if this is really the midpoint, which again, we assume is true because they told us, that means that it would be an equal sign. Right? So that we know that those two sides are going to be equal. From here, we can start doing our algebra stuff. So 7x minus 4x. Now I'm gonna keep x positive. That's generally what I like to do. So this will cancel. 7x minus 4 would be 3x. The 16 stays there because we didn't do anything with it, right? The negative 16 is still there. But now that we got the x on one side, we chose a side for the x to go on, and I decided to keep it positive this time. I'm going to go ahead and add 16 to both sides, so that way we get this away. So we want to kind of get all these numbers away from that x. Divide by 3. X equals 6. And it looks like we're done, right? So make sure we read the questions, right? Kind of like what happened earlier today. If you stop here and it says, it's asking a different question, like it might ask you, what is the measure of side QR or something like that, which in that case, well, we answered it, but not really. We didn't answer the question, so we got to make sure that we answer the question that they want, all right? So if somebody asks you a question, make sure you answer their question. So it's like, if somebody asks you, what's your favorite food? And you say blue, that doesn't really answer the question. I mean, it's an answer, it's true, but it's not what they were asking for. All right, let's go ahead and move on to the next one here. All right, so number 9, if H is the midpoint of GI, okay, so again, we have to believe it's true, find GH. So this one actually wants us to find one of the sides. Now, since it tells us it's the midpoint, it's the midpoint, well, we have to assume it's true, which means that I'm going to go ahead and put these two things equal to each other. And then again, I'm going to keep the x positive. So we looked for parentheses, none. Like terms on the same side, none. So what I'm going to do now is pick a side for the x to go on. Now, if I minus 9x, it's going to cause it to move to the left, but it's going to be negative. And me personally, I like to keep the x positive. It's just less confusing, especially when you have those inequalities, those less than or greater than signs. A lot of those can be confusing, and you have to remember a whole bunch of different rules for them. In fact, if I ask you right now, what's the rule for switching them? Some of you guys probably wouldn't even know, which is why I usually tell people, just keep it positive, right? Just stay positive. But we're not working on that right now, so let's go ahead and skip that. Let's see, get rid of this 10. So, right, we have a minus 10, so to get rid of it, we have to do the inverse operation. So that would be add 10 to both sides. 12 is what we get from adding 2 and 10 together. And now if I ask you what number times 4 can give me 12, you'd probably know that right away. Right, 3 times 4 is how you get 12. So some of these are pretty simple. You don't have to do that last step where you're like, let's see, divide both sides by 4, which in this case, it would just be 12 divided by 4, which is 3 again. But either way, now we have one piece, but this isn't quite our answer yet. So again, we might stop here and be like, okay, well, we found X, we're done. But remember, the question's not asking for X, it's asking for GH. So what we have to do is we have to take GH, and actually really what we could also do is we could also plug it into that one as well. All right, that would work out. You would still get the right answer. But sometimes, you know, there might be a little bit of a trick to it. So I'm going to just stick with what we've been doing. So I'm going to go ahead and take 5 and take out the X and replace it with 3. 5 times 3 would be 15 plus 2. And that means that GH is 17. Now to write the answer, GH equals 17. And I'm going to put the little line segment mark on top of it. That way, again, we're marking what we're working with. Because it asks for the length of GH. Ooh, kind of hot in here now. I'd like to open a window, but I'm afraid I'm just going to let more of the hot in. Maybe I'll open my door. Okay, well, I'll decide what to do after this one. So hopefully you got that one. Worked on. All right, so now we have 9. So let's move on to 10. And I'm going to see how many more we have. Oh, what do you know? We're almost already done. I think we only have this one here. So R is the midpoint of QS. Right, so R is the midpoint, QS is this whole thing. So let's go ahead and start working with this one. 2x plus 16 equals 5x minus 17. Okay, now, well, let's just use our basic algebra and see what we get. So minus 2x. And that would be 16 equals 3x minus 17. And so just keep this the same. The only thing we changed was this. And now I got to get rid of this negative 17. So to get rid of the negative 17, we do the opposite and add 17. And that would be 16, 17. So that would be 33. Yeah, I think it's 33. And it kind of works pretty nicely. I don't think there's any decimals or fractions on these. So I'm pretty sure most of these are going to come up as whole numbers. And then I'm going to divide both sides by 3 so that it cancels 3 here. And now I just got to ask myself, okay, 33 divided by 3 is 11. So I got one thing, right? We found the x, but that's not what we're looking for. It's not what we're looking for. So QS, that means the whole segment. So I'm going to plug it into here. So 2x, so 2 times 11 plus 16. Now, if it was just asking for QR, we could just do this and be done with it. But it also wants the whole thing. So this means we're going to have to add the other one to it, 5x plus 17. So this RS segment is going to have to be added in there as well. Oh, I put x in there when I meant to put 11, because we now know that x is 11. All right, so let's go ahead and evaluate this. So 2 times 11 is 22, plus 16, plus 55, minus 11. I'm sorry, minus 17. A little bit slow on the reading there. All right, now I'm gonna go ahead and get my calculator out, and let's see, I'm gonna have to do a couple of, move around a bit. Oh, there's my calculator. 22 plus 16 plus 55 minus 17. And that would give us the length of the whole thing. So I just did all that at once. So QS is equal to 76. All right, and that's it for number 10. Now, I looked ahead a little bit and I noticed that there is actually, I think my first hour is a little bit more ahead. I think they did 2 lessons today and we're still on the first one. So I think we might have to go a little bit longer on this one. All right, but anyway, let's get to number 11. And I think, how many are there altogether? There is going to be 11. Okay, so 11 is the last one for now. All right, so for this one's kind of a weird one because, well, let's start working on it and see what happens. So again, G is the midpoint of this segment, FH. FH is 6y minus 2, find y. And this one's a little bit weird at first because, hold on a minute, we're given x, now we gotta find y. Right, that's weird. So if we were to try to set this up and do it all at once, we would not be able to. If we did something like this, we can't do this. We can't use a segment addition postulate because, well, there's x and y, and you can't solve something. You can't solve something if there's 2 variables. So we're gonna have to use the midpoint to do this, right? So the bisector says that these 2 things should be equal to each other. Okay, 7x minus 4x would be 3x. Add 12 to both sides. So I'm just doing my basic algebra stuff, okay? Add 12 to both sides and that should get that x closer to being by itself. Now I'm gonna use reflexive property here. You notice how x is on the right side. Since x is on the right side, well, all I'm gonna do is I'm gonna flip it, right? I'm just gonna flip it so that x is on the left side now. And then whatever's on this side should still be the same. It shouldn't change anything. So 15 divided by 3 is 5. All right, so we still gotta plug this back in. We know what x is, and we know what the whole thing should be. So now we have to set it up. So 4x plus 3, set it up the same way we tried to earlier. 7x minus 12 equals 6y minus 2. Now we know that x is 5, so I'm gonna go ahead and drop 5 in where x used to be. And then we're just gonna evaluate this as much as we can. So now we have parentheses, so let's go ahead and multiply those out. Well, technically they're multiplications, they're not really parentheses, but which is why I sometimes don't like PEMDAS. And then I'm gonna go ahead and put all this together. So this is gonna be 23 plus 35 minus 12. That's gonna be 46 equals, nothing changes on this side, so I'm gonna leave it as 6y minus 2. But I am gonna try to get rid of this here. Sorry, I know where that came from. All right, so this is 48 equals 6y. Then divide both sides by 6. And remember, we're trying to find the value of y. We're not trying to really find, much else with all this going on. And that's gonna be 8. So there we go, we found y. So we found x and y. So, well, in this case, y was the main thing we were looking for, but we had to find x first. And I'm gonna go ahead and kind of skip back to the skip back to the next thing. And I think we can go ahead and do this one kind of quickly. All right, for this first one, let's go ahead and just copy it down. And this is actually the next one. The homework is on there too. So again, I know some of you guys haven't got the packet yet. After this, I'm gonna go ahead and post the homework if you want to, and you can copy it down and turn it in, you know. But for now, let's go ahead and do this next part here. So I'm gonna try to do about, I don't know if I can get through 2 lessons a day every day, but I'm gonna try that. At least that's what it says on my lesson plan. And I wouldn't wanna have to change it. But like I said, the type of the course might change depending on what I'm able to, get. If I can get that old grade book, then your score from last semester is gonna follow you to the summer school now, to this class. All right, so the distance formula, we have this thing here. It looks pretty complicated, but it's a little bit more simple than you might think. So distance formula is how far something is from one spot all the way to the other spot. And this is usually used, well, it's in this case, this one's always used with the coordinate plane. So that's the thing with the x-axis and the y-axis and all the numbers that are in both of those axes. I say axes, some people say axes. So this is the main thing I want you to get, but we'll go ahead and cover this one. And for this first one, I'm gonna go ahead and let you know what's going on with it. So what they're doing is they wanna find the distance from here to here. Now, with that, they are gonna plug these in. So there's an X value and a Y value in each ordered pair, right? So they take the X and the Y value and they plug them into these bubbles here. So we take in this case, it looks like they're taking this one and they're putting it first. Now, if you take the first one from this group, you're gonna have to take the Y as the first one in the next group too. So that's where this -2 comes in. The formula says that you should use a minus. So X minus X, or in this case, Y minus Y. Y minus Y would be this first one. And the second one is X minus X, which actually, did they do it backwards? Okay, I'm pretty sure they did it backwards because 3 are the Y's, but that's actually not really that important. So in this case, they did make the mistake, but they still got the right answer. Okay, still got the right answer. Which what I mean is, it looks complicated, but once you kind of know the basics, it's actually not very difficult. Now, for the next one here, they got the -5, and they put it in this group here. Now, the formula has a negative, but this 5 brought its own negative, so we end up with a double negative, which means that they're going to add them together. So this is like -2 plus 5, which is 3. 3 squared is 9, and that's where they got this 9 here. And then here, where they got the what looks to be the Y values, but they put it in the front. -3 minus 3 would be -6. But if you square -6, it becomes positive 36. Now these should always be positive. You cannot have a negative distance. So these distance formula things should never come out negative. If it ever comes out negative, you know, check your steps again. So from here, add these two together, so we get the square root of 45, which actually I think I still have that up. Nope, I don't have it up. Now, since you're on a computer, you're watching it from here, so to get, you know, if you don't have a calculator, you can always just use Desmos. It's what I always use, so DESMOS. And let's go ahead and type in the square root of 45. Now, Desmos is a graphing calculator, but you can use it with just about anything. In this case, we used it with square roots. And even then, I think most computers will have an app for calculator. but I'm just showing you another way to do it. And it's good to have, well, I encourage my students to use Desmos a lot because you're going to use it during, what test was that called? I know there's a test at the end of the year they usually give you. It's the one where you have to go into the computer lab and do all this stuff, but they'll give you Desmos to use. So it's good to have it. Anyway, with the Desmos, it says 6.7082039.325, but here they just simplified it. They rounded it off to 6.7. All right, I'm gonna go ahead and look at this one. So we have -4, 1, and 3, -1. And I'm gonna go back over to the work page. And I think this is the right one, 4, 1, and 3, 1, 4, 1, 3, 1. Just gonna double check to make sure I'm actually doing the right one. All right, so I got that one, and then again, I'm gonna try to complete this page and then we'll be done for today. All right, so again, we're trying to find the midpoint, or I'm sorry, distance. Sorry, distance. Let me use the same words they're using. So that is to now, if you have your worksheet, should be pretty easy. Now, I'm going to show you an easier way to remember the midpoint. I'm sorry, the distance formula. I'm getting all mixed up now. So distance formula. So to find the distance formula, again, it looks pretty confusing, but there is one simple thing you can do to remember it. So here's how I remember it. Sometimes you draw a picture. So in this case here, imagine this is like a hat. Okay, there's a second way you can also do this too. But you could probably imagine this is like a hat or a helmet or something like that. Like a motorcycle helmet. You know what, that's a good one. I'm gonna call it the motorcycle helmet. And if you're gonna be riding a motorcycle with a helmet like this, you should have goggles. So there you go. The little goggles are joined by the little thing in the middle. But who is driving this motorcycle? In this case, it's a goat. Or maybe it's like a sleepy owl. Now this is really what you need. This is the most important thing. Maybe it's like a sleepy owl with his eyes closed, or maybe it's a goat on a motorcycle. Whatever you want to think of it as. One other one that you can think of it as is you can think of it as a tractor. Okay. And then these are the big tires. And there's the front loader. Okay, but whatever helps, this is what you need. Now, if you remember that other example, the one we just got done covering, you don't actually need to put the X and the Y in the right place. You can switch them and you'll still get the right answer. But the important thing when filling it in is you've got to remember X with X, Y with Y, okay? That's the only thing you got to remember. Oh, one more thing. Whichever one goes first has to go first in both of them. So let's make this one go first. All right, so X is gonna go first, -4. And since this is the Y, it has to go in the other bubble. And then we do the same thing. Now I'm putting X first just because it's a lot easier, at least for me, to make it go first, because X usually goes first anyway. So 3 and then -1. And we also have to square this as well. So both sides are going to be squared. And it's squared because square and root, if you remember, are opposite operations. They're inverse operations. So let's go ahead and just start evaluating this now. So let's work with our parentheses, -4, -3. We have -7 plus, and here I have 2 negatives, a double negative. Now, normally I'd put these in a parentheses, but I don't want it to be too out of the ordinary. So I'm going to go ahead and just 2 plus 1. So remember, if you take away a negative, it becomes positive. So if you have something that's bad, like you have I don't know, bees in your front yard, and you call a beekeeper to take them away, that's good, right? If you have an illness and you get it removed, that's good. So that's what's happening here. So that's why this became 2, right? That's 2 plus, or 2 is from 1 plus 1. But that's kind of a basic thing, just in case you needed a refresher. -7 square is 49 plus, and then square 2, you have 4. 49 plus 4, that's going to be 53. Now I'm going to go ahead and use my calculator on this one here, and I'm going to find out what the square root of 53 is. 53 and then square root, which is this button right here. So I'm going to use my actual calculator for this one. And just to round it, I'm going to round it off to 1 decimal place. Okay, I'm going to round it off to the 10th. So this is going to be rounded off to 7.3, just because 8 is larger than 5, so we round up. Okay, hopefully I shouldn't have to remind you how to round off. But in this case, it would, oops. I accidentally closed the whole thing. Okay, now I forgot what I forgot what was written there. 7.3, I think, because I closed out the entire thing. And I'm going to use a little squiggly line here, right? Because you might have seen that one on the last slide. I didn't point it out. But if you're paying attention, you notice that there was a squiggly line, and that means approximately, right? So it's not exactly, it was like 7.28 something, something, something. But in this case, hopefully 7.3 is enough to, close enough for this answer. Okay, let's go and do this one. So again, let's do the same thing. So we draw the helmet. And now we need the goggles. And the goggles need to have a little space between them. We're squaring them. Now, if you really want to memorize the formula, it's on your packet, or you can just look it up online. Just type in distance formula, and you should get it pretty easily. But I'm just telling you a way that you can remember it. So again, we got to draw the helmet, the glasses, and the goggles, and we got to make sure it's squared too, right? So these are, and then we got to put the goat eyeballs in there. Or octopus eyeballs. I don't know. Some animals have sideways eyeball openings, which is kind of weird though. Why would a goat have a sideways eyeball opening? I don't know. Maybe it helps them somehow. Anyway, X, Y, X, Y. Now, again, for me, I just like to put X first. For me, it just makes sense. -7, right? And if this is X here, this bubble will be Y, and we have to take the first one from each of them, from the same one. So since we took the 7 from this one, we're gonna have to take the -2 from this one here. And then X goes first. And again, you could even switch these. You could switch the number set. So you could have -7 and 11 into this one, and -2 and -3 into the first one. But you got to make sure it stays X with X, and you got to have the first one from each group stay the first one in each of these bubbles here. And that's why they have the X1, X2 thingy. But again, if you want the formula, you can go ahead and look the whole thing up and write it down somewhere. But this is just an easy way of remembering it. Anyway, let's go ahead and put this together. So negative is going to make a bigger negative. So this is going to be 18, well, -18 squared. Plus, what do we have here? -5 squared. And the square kind of needs to be there because if you remember, you cannot have a negative distance. Now, I know, I don't know what the square of 18 is. Square of 18 is 324. And then I need to take the square of 5, which is pretty easy. 5 times 5, or in this case, -5 times -5 is still going to be +25. And I'm going to add those together, and that should be square root of 349. And I need to take the square root of 349. And that's going to be 18.7, it looks like. And we're going to say EF is approximately equal to 18.7, which actually, looking at this one here, I did not do that with this one here. To write the actual answer, we should get used to putting the answer in the appropriate format. Which I guess if you did that, I probably wouldn't mark it wrong. I wouldn't, if you just left it at 7.3, I'd be like, okay, fine. I know what they did. I know what you're trying to do. All right, and for this one, I'm going to switch back over to the other one. This one's kind of, well, I don't want to say it's easy, but it's very similar to the one we just got done covering. And for this one here, you can go ahead and just copy it. Again, not particularly difficult. So go ahead and just copy it down. I'll give you a minute or two, and we'll just kind of go through it a little bit together. But most of it should be there. So basically, to find the midpoint, they are going to have like there's this formula, and it looks a little bit confusing because it might look a lot like the one that you just it might look just like the one you just got done, the one we just got done doing just now. But it's, again, you just plug in some numbers, work a few things out, and that should be it. I'm gonna try to get the slides ready for the next one. 7. All right, so let's go ahead and get ready to go over it all together. Whew.
No, can you go back real quick?
Okay. Oh no, I accidentally changed it. Yeah, okay, I didn't see that. I didn't see I knocked it. I knocked the thingy. All right, we're gonna start in just 1 second. I just need to get one more thing set. That's weird. I had more hangups with my first hour, yet this one's taking a little bit longer. Okay. So to find the midpoint, we're going to add x to the other x and then divide it by 2. Basically, you're just finding the average of both of them. So if you had that string, where's the middle part? So here, they just take these numbers. So, remember, each of these is an x and a y. So 7 is x, -5 is y, 9 is x, -1 is a y. So they just put them in there, x's to x's, y's to y's. And what this is that it's just a huge ordered pair. So this whole thing is your x value. So by dividing it in 2, essentially, you're just getting the, by dividing it in 2, you're just, well, slicing it right in half. Simple as that, right? So halfway point is going to be dividing it in 2. And you do that same thing for the y value as well. So once you plug these in, add them together, and that should give you your midpoint formula, or your midpoint. And with these, I'd like to go over them and kind of talk about each one of them, like show you on a graph sort of thing. But again, this is kind of a review for you guys. So maybe you've already done this before a long time ago. So this is more of a refresher. And again, anything we cover in class, even if you already worked on it with the other teacher, you're still going to get points with this one.
Oh, your room is also cold.
No, I was feeling hot. I don't know. I thought my room was kind of
I
hot.
cannot stand with this kind of temperature. That's what my room is. That's why I told him my room is super cold. Do you have a stapler that I can wear?
Sure thing. Okay.
Thank you. Oh, hold on.
Hmm.
Because they keep on changing the. Never mind. It's okay. Thank you.
Okay. All right. So find the coordinates of J if K is -5, 10.
Time.
What's that?
It's already 1:47.
147?
Oh, we have to end until 2 o'clock, right?
155 is what the schedule. Did they have a new schedule? They better not have come out with a new schedule if I'm still using this one. All right, where was we? -5, 10. So here, go back 5 up 10. And this will mark this one K. And we have a line JL. Oops, K, I forgot the bottom part. Midpoint of JL. So there's a line, JL. We don't know where it is, but we know that L is also -8. So go back 8 up 6, and that would be about here. Okay, this is not a perfect graph. In fact, it's very rough. And actually, this one should be a little bit higher, just to give us a better idea. And then we have L here. And midpoint of JL. So there's a J somewhere. K is the midpoint. So J is probably going to be like right there. Sometimes it helps to draw these. Sometimes it doesn't really help. Okay, but the reason I wanted to go over this one was because sometimes you go the opposite direction. Right, you'll go the opposite direction. You might have put J over here. So anyway, let's go ahead and, well, we got to find out where J is. It says here, find the coordinate of J. So let's go ahead and use that midpoint formula. So it's a big ordered pair. So ordered pair, big ol' X, big ol' Y. But we're going to have to divide them by 2. So it kind of looks like a, I don't know, like a, kind of looks like another face again. All right, maybe it's like a big old eyebrows or something. Now we have X and X, and we're adding them, Y and Y, we're adding them. Now these ones might be a little bit tricky because the other one we had to use the minus. On these ones we're using a plus. So let's go ahead and start plugging in our numbers of what we know. So we know that this is the X, this is the Y, this is the X, this is the Y. Now, this one's a little bit of a trickier one because we're not just finding the number, because we know that we know the midpoint. We know the midpoint. We know that it's 5 and the other midpoint is 10. So we put them in like that. And this would be Y minus, and we're gonna have to use these Y's of the other one, the one that's not the midpoint. So in this case here, that'd be 6, and this one would be -8. And the bottom number is always 2. let's go ahead and put this in there. So -5 equals, shoot. Well, to get rid of this, what I'm gonna have to do is I'm gonna have to double both sides. I'm gonna have to double it, because remember, this x is being divided by 2. So we do the opposite of divide by 2. We times it by 2. And if we times it by 2, this 2 is going to, on the bottom, because we don't want the fraction, we want to get rid of fractions whenever we can. They're kind of like parentheses. We want to get rid of them as soon as we can. And then for this one here, I'm going to have to double both sides of this one here. Double, and this is just to find the y coordinate. So if I double that, I get y minus 6. And we're still looking for an ordered pair, so I could add, well, no, I'm gonna have the -8 in this case here, and add 6 here, add 6 here. And we get x is equal to -18. And y is, no, something doesn't seem right there.
Are we adding instead of subtracting, Mr. Ness?
Which one?
The x1, x2, and then the y.
Oh yeah, that's right. I even said that. Yeah, we're supposed to be adding them. Oops.
Huh.
Here, I wrote it wrong as an example, and I ended up just keeping it. All right, yeah. So we got to add these together. Well, well, let's see. We don't need to change everything. Let's just change what we need to. So that would be that would turn this to a negative, which would mean that we'd have to add this to both sides. And that would change this into a -2. That should be -2. And if we look at where J is, see if we go back 2, because remember this is 5 and this one is -8. So 2 kind of makes sense where J would be. And let's also, while we're here, let's try to guess where J would be. So how high do you think J is? Just a guess. Okay, you might not have to say it. I know some of you are shy. All right, but I was thinking it's about 12, maybe 14. And sometimes I like to tell students to kind of guess at something first. So if your guess, like let's say we worked on this and it was way off, all right? And that's how I kind of knew something was wrong right here, which is actually a good thing because now you can see that I said, wait a minute, negative, I don't remember what it was, like 18. -18 would be way back here. We'd be way off the paper of the graph. So it's not that. So in a way, it's a good idea to guess at it before you start working on it. That way you know if your answer seems off. And in this case here, y would be equal to 14, which is what I guessed, right? We guessed it was around 12 to 14. And if it's about 12 to 14, back 2 up 14 looks like it would be exactly where J is. So that's how we know where that point is. So I'm gonna go ahead and put that point right here. And that is gonna be parenthesis -2, comma 14. So that's our ordered pair. And we should also label it because it wants us to find point, what is it, J? Yeah, so we're gonna put J here. So we're gonna mark it with a J. And if you just put -2, 14, you know, I'll take it. I know what you're saying. But it's always a good habit to kind of label and show what you're using. All right, and I think we skipped 6. I think 6 is actually out of order in this case. So we actually did number 7. I hope you guys didn't fill it in for number 6. But we'll go ahead and end here. It's about 1:55 anyway, so we're out of time. I'm gonna go ahead and go back to the other screen, but just to remind and let you know a few more other things that are going on. But I'm gonna go ahead and